morning guys, we are from group 13 and now I will tell you about the people in our group. The first is me, Cesario Sacornelis.
Hi Bre, I'm Willy van Alenbruto, I'm from North Sumatra.
My name is Panji Prasetya, you can call me Panji, and we will be explain about first law of thermodynamics and second law of thermodynamics, also relevance of thermodynamics in the past until now. Thermodynamics is the study of the system involving energy from the heat and work. Yang lagi.
Created using Powtoon.
Principle of the first law of the thermodynamics is the version of law to conservation of the energy. Adapted for the thermodynamic system, the energy can be transformed from the one to the another, but you can't be create or destroyed. So you can be summarize this principle by the famous maxim: nothing is lost, nothing is created, everything is transformed. And here we understand the value of the first law of the thermodynamics, the contraption of the thermal machine which have to convert heat into work. And the example is steam engine and order transform the work into heat, the heat pump, the refrigerator and air conditioner. Thank you.
Created using Powtoon.
About the second principle of the thermodynamics. The second principle is stated as follows: any transformation generates the thermodynamic entropy. The entropy is an extensive quantity and is defined as the change during a reversible transformation is equal to the amount of heat given to the system divided by the temperature of that system, and you can see the equation 1. Transformation is irreversible, then there is a creation of positive entropy due to dissipative phenomena. For example, friction, diffusion, and etc. And you can see the equation 2. And we can deduce the famous inequality of Clausius, which summarizes the second principle and is represented in the inequality. And you can see the third equation. Transformation is not perfect. All non-real transformations are irreversible and will create entropy. The total entropy of the universe is in constant increase since its birth. This statement is very important in thermodynamics and many fail at the scientific level but also at the philosophical level. For the construction of thermal machines, we must understand this principle that the entropy generation is a problem created because the entropy will decrease the future performance of the machines. That means making machines that minimize the creation of entropy, mainly to minimize the friction loss. It naturally includes an engine that runs very quickly will have better performance if the friction is minimal.
Created using Powtoon.
Applications. A. Extraction of iron from its oxides. In a blast furnace, oxide ores of iron, after concentration through calcination or roasting, are mixed with limestone and coke, are fed from its top. Hot air is blown from the bottom of the furnace and coke is burnt to give temperature up to about 2200 Kelvin in the lower point itself. The burning of coke therefore supplies most of the heat required in the process and will be oxidized to CO. The CO and heat moves to upper part of the furnace. The upper part, the temperature is lower and the iron oxides Fe2O3 and Fe3O4 coming from the top are reduced in steps to FeO. Limestone is also decomposed to CO, O which removes silicate impurity of the ore as slag. The slag is in molten state and separates out from iron. Thus, the reduction reactions taking place in the lower temperature range and in the higher temperature range depend on the points of corresponding intersections in the delta R G minus versus T plots. These reactions can be given as follows. At 500 to 800 Kelvin, lower temperature range in the blast furnace, 3Fe2O3 plus CO gives 2Fe3O4 plus CO2, equation 11. Fe3O4 plus 4CO gives 3Fe plus 4CO2, equation 12. Fe2O3 plus CO gives 2FeO plus CO2, equation 13. At 900 to 1500 Kelvin, higher temperature range in the blast furnace, C plus CO2 gives 2CO, equation 14. FeO plus CO gives Fe plus CO2, equation 15. The iron obtained from blast furnace contains about 4% carbon and many impurities in smaller amount. Example, S, P, Si, Mn.
Created using Powtoon.
Okay guys, let me explain to you about the conclusion of the first law of the thermodynamics. So the conclusion is, during processing in a closed system, the variation of internal energy of the system is equal to the quantity of energy change with the external environment as heat and work. The second is the conclusion of the second law of thermodynamics. The conclusion is, the concept of entropy is fundamental to understanding the law of thermodynamics. Entropy is defined as heat absorbed by a system divided by the absolute temperature of the system and the time the heat is absorbed. Absolute temperature is the number of degrees above absolute zero. The coldest temperature then can exist. Blast furnace is the first step in producing steel from the iron oxide. There are relationships with the law of thermodynamics with the blast furnace. The first relation with the first law is the conservation energy from heat to the work, and the second relationship with the second law of thermodynamics with the blast furnace is there are three reactions which is occur at the blast furnace reaction, such as 3 hematite plus monoxide produce carbon dioxide plus 2 magnetite. It begins at 850 degrees Fahrenheit. The second reaction is the magnetite plus carbon monoxide produce carbon dioxide plus 3 ferrum oxide. It begins at 1100 degrees Fahrenheit. The last reaction is the ferrum oxide plus carbon monoxide produce carbon dioxide plus ferrum, or ferrum oxide plus carbon produce carbon monoxide plus ferrum. It begins at 1300 degrees Fahrenheit.